Let's go over the fundamental theorem of calculus, and this will be part 1 of 2. There are two separate theorems that we can use, but they are interchangeable. So the first one says that if f is a continuous function on a closed interval a to b, and capital F is any antiderivative of little f on the closed interval a to b, then the integral from a to b of little f of x dx equals capital F of b minus capital F of a. And so what this basically means is that if we have a definite integral, with basically meaning a definite integral is where we have an upper and lower bound, and we're basically finding the area under the curve. That is what a definite integral is. And it also means we get a definite answer, meaning that when we do use a fundamental theorem of calculus, we get an actual answer under the curve, rather whether we might be thinking of also an indefinite integral, which is basically where you take the integral of something and you get like a plus c, where you get a function of the area under the curve. And so basically what this means is that we can take the antiderivative or the integral of f of x, and what this ends up giving us is capital F of x. And then all we can have to do is plug in b into that new function and plug in a from that into that new function and subtract the upper bound from the lower bound, basically. And that's how we get the area under the curve. And so a visual of this is if we have, let's just say this is f of x, and we have the area under the curve from a to b, and this is all the area, the fundamental theorem of calculus gives us the exact value under the curve, rather than having to use Riemann sums to approximate it. So let's go over an example. So we have the integral from 2 to 5 of 2x dx. So first, let's do the antiderivative. So we have 2x, and this is to the first power. So we're just going to plus 1, and this is going to equal 2. That means we're going to divide this by 2. So we're going to get x squared, or 2x squared over 2, and the 2's cancel out. So we're just going to get x squared. So now we already did the antiderivative, right? So the integral of 2x is x squared. So we're going to have x squared, and we're going to write this in brackets from 2 to 5. And so now we're going to do 5 squared minus 2 squared. And so this is similar to what we have here of f of b minus f of a. All we're doing here is just, this is our capital F. And so we're going to get 25 minus 4, which is going to equal 21.